So these sensors are in the field throughout the growing season, and they monitor total nitrogen, so both nitrates and ammonium. And they can tell the farmer when and where in that field fertilizer needs to be applied.
Fertilizer is one of the highest costs when it comes to consumables for farmers, along with seeds.
Fertilizer can be up to a third of their costs, farming costs, so it's a big, potentially a big cost savings if we can reduce even a portion of that. This really gives the farmer an opportunity to practice precision agriculture. This way they can do kind of a spoon feeding of the fertilizer throughout the growing season, so they only apply it when and where they need it. We have a manufacturer make basically a printed wiring board, a type of circuit that's common in electronics, and then we put our sensors on top of that. We convert some of the polymers that have been put on top of that printed wiring board into graphene. It's a 2D nanomaterial.
So the method that we have developed is scalable. It's a way that you can produce multiple thousands of sensors at once using materials that are readily available. So the cost can be considerably low.
This allows them to do continuous soil sampling without that expense of having to ship it off to the lab, but they can get results immediately. They can monitor it so they can still have their maximum yields, but at the same time we can show them you can get those great maximum yields but still use less fertilizer and have less agricultural inputs. The goal is to have it for the entire growing season, so approximately up to 4 months in the field, regardless of the temperature swings and the types of rain events and so forth.
So it's a type of sensor that you can just implant in the soil. It's like what we like to call bury and forget.
It's been really exciting to see, I think, some of our technology, these nanomaterials actually going into a commercialized product and helping the farmer.